All right. Welcome back, everyone. Anyone? Maybe no one. um, in this video, I'm going to be rebuilding example number one from the Generative Design book in TouchDesigner. In the previous video, I walked through all of the JavaScript code step by step. Hopefully somebody got something out of that. And this video, I suppose, is more for either those familiar with the JavaScript portion who are curious about how the TouchDesigner translations work, or someone who's new to Touch and finds it helpful to listen to someone actually step through a reconstruction of the network. And I say reconstruction because, as I mentioned in the previous video, I will be leaning heavily on the work done by Derivative or somebody at Derivative, I believe, who has already done 99% of the work. I just decided to go pick through it myself, and I found a lot of the examples really interesting and informative and illuminating. Learned some tricks along the way, and I thought I would have enjoyed listening to something like this. So here's my attempt. So the example that we are looking at is number one, which again is a pretty quick one. It's the inner square grows as the mouse moves across the sketch in P5 terms, and the what do we call it in Touch? The display, the output. The inner square grows, right? And the two colors of the background and the inner square, as the mouse Y goes from top to bottom, are inverses of each other. So they run the gamut of 0 to 360 in hue speak, right? HSB color space. I said in the last video that they're complementary colors. That's actually not true. And that was a bit of an error on my part. Complementary colors are opposites on the color wheel all the way through. These are not. Clearly not. Like, they both start out at red. Those are not complementary. When they get to the middle, they're both blue. Obviously not complementary. They do reach a complementary color sort of about 25% down, and then 75% as well. And it might be an interesting example to actually build something that maintains its complementary colors and cycles through while keeping that relationship. But that's not what this example is. So let's enough talking. Let's code this thing. So step one is let's adjust the size of our canvas, because obviously by default we have a 1280 by 720 canvas. So in Touch, we head over to the outer layer of our project, head over to the container parameters, layout, and we want a width of 720 and a height of 720. And now if I'm just going to adjust my my monitor setting so that when I press perform mode, we get a beautiful black 720 by 720 square. Excellent. Step two, let's create a background. Now in Touch, there are like 500 ways to do everything in Touch, which can be a blessing and a curse. Probably the easiest way, and the way that they use in the example, is to have a constant top. Just fill up the entire space of your window. So let's do that. Now by default we have 256 by 256. If we head over to the common page, we can hard code it, or we can just use the handy drop down option parent panel size, and now we have a 720 by 720 constant. I'm going to hook that up to an out, and that way when I press perform, we get a white background. Sweet. And we can see that that's connected. Let's make that turquoise or whatever. Perform mode, boom, turquoise. Love it. Now, color. In both P5 and Touch, the color inputs or the color arguments are by default RGB, right? This is a standard for computer graphics, of course. So if I have full red and 0 green and 0 blue, we get red, right? Now, similar to the other example, in Touch as well, we want one value to be able to control the entire sort of lookup of the spectrum, right? Now, there's two ways to do HSB or HSV, as Touch calls it, right? Hue, saturation, value. We have the HSV adjust, and we have the HSV to RGB. I'm just going to briefly explain both of them. If we connect our constant to the HSV adjust, here's what we have. There's a lot of different parameters. You can sort of hone in on exactly the range that you want to adjust. The value that's important for us is this hue offset value. Now, basically the way it works is that if you start with a color, let's say blue, right? And then you use this hue offset, as you move from 0 to 360, you will cycle through all of the different hues. That's exactly what we want, right? Except instead of starting at blue, we want to start with red, like the example. Yeah, if we look at our example, we get red all the way to red. So this is the solution for us. 0 to 360, we need to somehow map our mouse Y to that range, which is very easy to do. Now, the other way to do this, which we won't do today, but just thought it'd be worth explaining it. If we hook the constant up to an HSV to RGB, just as the name suggests, the HSV to RGB converts HSV to RGB. So what that means is it will treat every RGB value in every pixel, instead of treating it as the red, green, blue value, it'll treat it as the hue, saturation value. So what that means is essentially, instead of these three inputs on the constant being red, green, blue, these three inputs still on the constant, not on this one, there's actually no parameters on the HSV to RGB. These three parameters will actually represent the hue, saturation value. So even though it's white in the top viewer on this constant, what we're actually looking at, it's kind of strange. We want to adjust the parameters on the constant to give us the output of the HSV RGB. It's a little bit, it's a sort of an unintuitive way of working, but it does mean that we can just use a single 0 to 1 value, right? So we're looking here, but we're adjusting on the constant. So this way we've got, if we go from 0 to 1 in the hue range, that's going to cycle us through all of the hues, right? So starting at 0, and we move all the way through some sort of bluish color, cyan probably, and then we get all the way back to red, right? If we adjust the saturation, that's going to take us down to white when we have 0 saturation, and of course brightness is going to move us towards black, right? So it's sort of a strange way of thinking, because again, we're actually inputting into the RGB inputs on our constant, but we're controlling the HSV. So anyway, that can be useful too. Let's not do that. Instead, let's do the first way. Now, let's what am I doing? Let's do this. So we're going to start with our red background. Let's just perform to make sure. Yep, we got a nice red background. Excellent. Let's go ahead and hook the mouse up now. Let's do that. Let's switch gears. So to grab our mouse, we're going to use a panel chop. Where's our panel chop? Our panel chop. Now, if I press Shift V to bring up our parent viewer, I'm just going to make this a little bit smaller so it doesn't take up the entire screen. Let's have a look. As we drag our mouse along this panel, we can see two values that kind of act as what we want. There's a roll U. Not entirely sure what that does. If I thought about it for a second, I'd probably figure it out. But more importantly for us, we want inside U is basically equivalent to P5's mouse X, and inside V is equivalent to the mouse Y. Now inside V goes from 0 to 1 as you go from bottom to top. In P5, the mouse Y goes from 0 to height, but 0 is at the top of your canvas, right? Excellent. Let's go ahead and let's use some of the things that I kind of like. Here would be the normal way, right? Normally, in order to get the values, we would select our inside U, and then we'd create another select and select our inside. What did I do wrong? Inside, sorry, not Y, inside V, right? And then we would maybe rename them to mouse X, mouse Y. Handily, the panel chop actually lets us select things directly and rename them. So I'm going to go ahead and do that. Let's select inside U, and we could actually just type this inside V, and now we've got our two mouse X and mouse Y parameters. We could rename them to mouse X and mouse Y too if we wanted. Mouse Y. I don't need to do that. Let's keep them how they are. Sweet. So, quick and dirty thing we could do. Anytime we want to map a value, we could just go like so. Again, we could just go directly. We could viewer active. We could grab the inside U, and we could go straight to. Ooh, no, we can't do that because we need to range it, don't we? So let's do that. Let's grab a math. And here's another little thing from the example that I kind of didn't realize, or maybe I learned and I forgot. If we want to range all of these things, we can of course go 0 to 360, right? So we've got the X going from 0 to 360 and the mouse Y. Now we only want the mouse Y, or the inside V to go from 0 to 360. We don't want the inside U, the X-axis to go from 0 to 360. So we could select them both and just apply the math to the inside V, our Y-axis, and then maybe merge them back together, put those into a null. But we can also, on the comment page, we can actually just specify the scope of the channel that we want to operate on, the channel we want this math operator to operate on. So we only want inside, not capital, inside V. So now our X-axis remains as a normalized 0 to 1, but our Y-axis goes from 0 to 360. Handy, you know, bit of a shortcut. The downside is it's less explicit, you know. There's kind of always this trade-off with programming, right? Where we could do things quickly and somewhat, dirty maybe is a weird word to use, but it's kind of a neat trick at the expense of readability. So I don't know. we could go full on readable and select everything out and make everything explicit and leave comments and leave text dats there and all that. But it's sometimes it's fun to learn a little shortcut trick. So there's a shortcut trick for that. Let's Alt N and put this into a null. Always best practice. Doesn't take any effort. And we can put that inside V directly onto our hue offset. Export chop. Sure, we can export to chop. And now we'll see as we drag our mouse from top to bottom, we get that entire color spectrum, which is delightful. All right, now to get our inner square, we could create a second constant. We could scale it with a transform and composite it. But since we're going to end up HSV adjusting anyway, what I think we'll do is we'll just middle mouse click and create a second HSV adjust, which essentially creates a copy of our constant anyway. And I think what we'll do is we'll copy the parameter of the offset. Again, we'll try to keep things as similar as possible. So here we've got our mouse Y mapped from top to bottom, 0 to height, to 0 to 360. That's equivalent of our inside V being mapped to 360, right? Now our opposite color, the square color, the inside square color, we could have called it, is 360 minus whatever that value is. Now we could be a little more explicit here, or we could just have a fun shortcut where we copy the value. I think I just did this. And then let's paste it on this hue offset. But let's paste the reference, right? So that we actually have this Python reference. And then we'll just make it the inverse by doing 360 minus, did I press minus? No, minus that color. And now, as we go top to bottom, we get the exact inverse color, right? And again, that's the equivalent of this. We're just taking whatever the mapped value is, and then our other color is the inverse. So we're actually almost there. All that's left to do is to composite these two together and then adjust the scale of the inner square, right? So let's grab ourselves a composite top. We'll add our inner square to it. Now, when we do, and we'll switch the operation to over, right, not multiply. Now let's have a look. So we've still got the background on top. So you see, so by default, the composite sort of works where the lowest input is the lowest layer, and then the further inputs, when I say the lowest input, I mean literally farthest down on the screen, like it becomes the lower inputs, becomes the lower layers, and then these ones at the top are actually on top. So that's why we can't see the yellow. Now, I never really enjoyed that way of working because I kind of, I don't know, like I like to, as I add more inputs to the composite, in my mind, those should be being stacked on top, right? But that's not how the composite works by default. As you add more things, you're actually adding them underneath, which I kind of find weird. Luckily, we can just go over to the composite top and boop, swap the operation order, which is sweet. So now we'll actually make this more explicit. There is a transform option on the composite top that will, transform whatever things are second inputs and more. We're going to be more explicit. This time, we're not going to go for the shortcut. We're going to be more explicit and add a transform top to our inner square. Cool. So we should see that as we adjust the scale of our inner square from 0 to 1, we essentially, yeah, we get what we want, right? So all we need to do is hook our inside U up to that. And we don't need to adjust it, so I'll just export it. And let's have a look. As our mouse goes from left to right, we get our inside square growing to fill the entire window. Perfect. And I think that's actually it. The only thing left, apart from saving, which I haven't done, but the only thing left would be to get rid of the mouse when it's in the window. And that's super simple. Let's just go up a level. We'll go over to our perform window. And there is an option about halfway down that says cursor visible. And let's go never. And we'll turn this off. We will press perform. Let me get rid of this stuff. And there we go. Mouse going top to bottom, red to red, and mouse going left to right. Lovely. And that's it. That probably took a little bit longer than I hoped. Hope that wasn't too much talking, but yeah. Anybody who stops by, thank you for stopping by first of all, and please leave a like or a comment, especially if anything you'd like to see different, or any feedback would be very welcome, because I would like to make this a thing, and I would like to add to the community as best as I can. So that's all for me. Take care. Till the next one. Bye.